Dust collection, the final frontier. These are the projects of the Barber's Paddock Workshop. Our mission, to improve airflow, eliminate clogs, and boldly attempt to print an ever-increasing large amount of round balls, all in the name of dust collection efficiency. So here we are again. Now usually when I design something, it's to solve a problem that I'm specifically having in the shop. And sometimes that doesn't necessarily extend to other people's shops, but often I'll share what I've made or designed with the rest of the world, and if it helps someone else, well, that's a bonus. So honestly, I never thought I'd be doing a part 2 to this project. If you're new to the channel, then hello, my name's Anthony, and for the last 3-ish years, I've been building out my very first woodworking workshop. And about a month ago, I posted a video showing the process of making and designing a ball valve blast gate for my dust collection system. And I made those files available for people to purchase in case it was something that interested them. Since then, I've been absolutely inundated with email, comments, questions, messages, requests to talk a little bit about the ball valve in more detail, and to also potentially make available some other sizes. Out of everything that I've ever designed for the shop, this has by far been the most interest that I've ever received regarding anything that I've ever made. So that's why in this video, a kind of part 2 follow-up, I wanted to answer some of your frequently asked questions, share a couple of the updates I've been working on, and show you some of the new versions of blast gates that I've been working on. So if you haven't already, consider watching part 1, because obviously that's going to give you a lot of context. But if you have already and you're really keen to find out more, then let's get stuck into it. So frequently asked question number 1 is, Anthony, what should I be printing the gate out of? And the answer to that will depend on where you live, but as an overall recommendation, regardless, I recommend PETG. It's the safest option that's going to be readily available for most people with 3D printers, as well as handle fluctuations in temperature and humidity. PLA is a perfectly acceptable alternative, especially if you are in a workshop that has very low humidity, very low temperature, or is climate controlled like my workshop. In fact, most of the ball valves in my workshop are actually PLA, but that's purely because I know that the environment is quite controlled. As a general recommendation, I say go with PETG, it's the safer option. Frequently asked question number 2 relates to how you print the ball itself, and that's, do I have to print the ball in 2 halves? So there seemed to be a bit of confusion about how to go ahead and print the ball for the valve. In the video, I recommended splitting the ball into 2 and printing them as 2 halves. And in the video, you saw me assemble them as 2 halves by gluing in some dowels and then gluing the 2 halves together. Now you absolutely do not have to print it as 2 halves if you don't want to. You can print it as a single ball, but you do need to make sure that you understand your printer very well, and I highly recommend that if you do it as a single ball, make sure that you add brims to the underside or where the contact surface would be on your build plate so that you can ensure good adhesion. And that's why, as a general guide or a general recommendation, if you feel like your printer might have those problems, then a lot of those can be addressed by simply splitting the print in 2 halves and printing them and then joining them together when you assemble. So it's got nothing to do with the design itself in requiring that you split the print in 2, and more to do about what the large bulk of people who are printing this will be more successful printing it in 2 halves versus trying to print it on a single, in a single build. So common question number 3, or let's say common observation number 3, is that a lot of people have commented that the orientation of the arm on my ball valve, or especially this one, is in the wrong position for the open. And I know that it might be sort of, I guess, best practice or engineering practice to have the position of the ball, open or close, indicated by which direction obviously the pipe is going. So obviously most people would consider this to be the open position, and people would consider this to be the closed position. So this was just a personal preference for me. I wanted to have it this way. It really doesn't make any difference in terms of performance or the way that the ball valve works. You can glue the arm in any orientation you want. So if you do want it to have in the open position and you do want to have this in the closed position like this, you can. That's the reason why I've also created the hard stops with the labels on it so that you can customize how you want that. I have updated the print files for this though to help you orientate that arm much more effectively so that you can have it exactly vertical to the gate, but you can orientate it any way you want. So yes, I have started doing it that way just to obviously appease the masses, but you are free to obviously have it in any position you want. So this particular one is an early prototype. It happens to have it in this position. It hasn't affected the performance whatsoever, but you know, if you do download this, you do you. Orientate the arm in any direction you want. So common question number 4, or really common request number 4, is about the batteries and how they've been holding up. Now, the original goal of this project has always been to create a remote controlled gate that ran off batteries. And it's because of that goal we used some very low power servo motors, and I'm going to talk about servo motors very shortly. But the battery performance has always been a bit of a question mark. It's always been something that we needed to test to really establish a baseline. When I recorded the previous video, I'd only been testing it in the workshop for a couple of weeks. Since then, I've had a lot more time with it, and I can say that the results, considering the size of the battery, are actually not that bad. In my testing, I've been able to get about a solid month of running from a single charge on these batteries. And to put that into context, that's probably about 4 workshop days, maybe pushing 5, maybe averaging something more like 3. So not terrible when I consider the battery size here, but probably not enough for general purpose or most people's setups. If you were more of a weekend warrior or only maybe once a month in the shop type situation, then it probably would be okay. So a thing to remember is that these batteries are very tiny. This one is about 800 milliamps. So to put that into context of, let's say, your mobile phone, that's probably a quarter of the size. So the obvious solution, as I mentioned, is to put in a bigger battery. And I have designed the case to allow much more capacity and more room to put in more batteries or a larger battery. And I think that's probably the solution I will explore, but it was good to have a baseline understanding of just how much power was required. This, however, actually ties into a feature or a update that I've been working on, that I've been testing, and I can say is working. And that's based on the common request of what if we ditch the battery altogether and plug it into mains power. So let me show you how that modification now works. So here's the original setup that runs on batteries. And as you can see, there's plenty of room inside here for a larger battery in the future if you want longer battery life. And that's something I am exploring right now. However, the most common request I received has been the ability to plug this into mains power. And honestly, the modification to do this was so simple, I'm not sure why I didn't try it earlier. So here we have the AC conversion of this particular component case. And as you can see, it's a very small modification. We've added this particular barrel plug, which then plugs into this AC adapter. And this barrel plug is then routed directly to our power switch. That's it. So those two components just look like this. So this is a standard power adapter, and this is a barrel plug. These cost next to nothing. Obviously the AC adapter is a bit more expensive, but the actual electronics, very simple once again. And all we needed to do is cut the end off here, strip the wire so that we could then screw this into the terminals on these sides. So there's a positive and there's a negative. You need to make sure you get those in the right order. But that's the modification, that's it. So once you have that, a hole in the enclosure in the side here. So there is an update, a slightly updated case design as well. Of course, that will be in the updated files. I've glued that in, so that is nice and solid, and it just wires directly to the power switch. So that is a solution that will allow you to run the gates pretty much indefinitely off power. So you're going to need a power point, and but you won't need any batteries. You won't have to worry about charging batteries. In fact, the only batteries you'll need to worry about are in the remote now. So this updated version will be available in the updated files. I'll talk about the files later on in the video, but that is another alternative solution for powering these gates. So you've got the battery version, and now you have a mains powered version. Future Anthony here, folks. I think it's important to pause and put a big disclaimer here, because it's one thing to be experimenting with batteries, but it's a whole nother level when you start plugging things into mains power. I want to be clear that I sought guidance on the correct AC adapter here and plug types to use from people who know far more about this stuff than I do. Now, my setup works safely here in Australia, but if you're adapting this project in another country, please make sure you fully understand your local power standards and voltage requirements. Consult someone qualified if you're unsure, especially when working with mains electricity. I've found that local hobby electronic stores are usually a great source of advice and knowledge, so reach out to those people if you need help. But most importantly, stay safe. Now, the next question I get asked a lot about is obviously the servo motors. And the servo motor that I used and am actually still using, especially in the manifold setup that I have behind me on my dust collector, is based on a micro servo. Now, I've been using these ones for a while now and I've had no issues with them. They're still working fine. However, there are some updates and some general advice that I'm going to share with you. So in front of me here, I've got 4 different servo motors. I've got 2 micro, 1 medium, and 1 large. And in the first video, I only had access to this micro servo from Bamboo Lab. And at the time I mentioned that I wanted to test the MG version, or the Metal Gear version, which is this one here. Now, generally, if you're using a micro servo, I recommend going with the Metal Gear model. It's probably going to be more durable and last longer over time. But having said that, I'm still using the original Bamboo Lab servos from the first video, and they're still going strong. So it is absolutely possible to build this project with these original units. Now, I've had a few emails from people saying they're struggling to get the ball to turn using micro servos. It's really important to do some processing on your printed ball and make sure that the surface is smooth with no rough edges, seams, or high spots that might catch the inside of the housing and create excess friction. So on your ball valve, you'll want to check the edges here. Make sure you don't have any sharp lips, because 3D printers do struggle to print sharp corners or sharp edges. So normally I run the sander just over this edge here. You also want to check about any print seams. So as you can see, if you can, there's a little print seam here. I normally sand that smooth as well. So just check for little things like that, including inside the ball case itself, because that might be impeding the ability for the ball to turn. So what you're aiming for is what I call the Goldilocks effect. It's just the right amount of friction, enough to hold a good seal, but not so much that the ball won't turn freely. So you want to be able to hear it slightly rubbing, but you don't want to feel it catching. So when you have your dust gate set up, just give it a couple turns and you might be able to feel and see if there's going to be any friction that's going to stop a servo motor from turning that ball successfully. Now, the other option is to simply step up to a larger servo motor, something with more torque, and that's what we have here. Now, these original servos are rated for about 1.5 kilograms per centimeter of torque. Now, this medium-sized servo is around 5.1 kilos, and this large one is rated for 20 kilos, as you see. So these are significantly bigger and also have more torque than these micro ones. Now, all of these still plug into the same controller. You don't have to make any modifications. And I have created mounts for each size, which I'll cover later in this video. The one thing to keep in mind is that larger servos draw more power. So that means that it'll shorten the battery life. However, if you pair that with your AC setup instead, so if you've decided to go down the AC adapter path, then power is pretty much irrelevant. You can go with a servo motor as big as you want. You just want to make sure that you have enough friction that the ball is going to have a reasonable seal while still maintaining a smooth operation. So again, if you prep your ball in the right way, a 1.5 in the 4-inch version is going to be can work and does work, but you may want to play on the safe side and go for something like a medium servo or even a large servo like this one. They are more expensive obviously as well, but these are also optional additions. So I have mounting plates and servo arms that are designed for all of these. So all 4 of these are updated in the files. So the final question I'm going to address is those who have asked, will I be making a fully assembled, purchasable ball gate valve available from my website? Unfortunately, the answer to that is no, and that's because I'm simply not set up for mass production. Now I can print one ball valve at a time. That's all I'm set up to do. So it's very time consuming to do. They do take some time to make, and I would have to charge an astronomical amount to make it even cost effective or even break even after you include freight and materials and all of that kind of stuff. So it's just simply not economics of scale aren't there, unfortunately, for someone like me. Now that's not to say that it won't happen in the future. There are some early discussions in regards to this. I can't really talk a lot about it because they are extremely early, nothing in concrete, and it may end up nothing coming of it. However, it's a possibility in the future. My general advice of those who don't have a 3D printer would be to, well, firstly consider maybe getting into 3D printing, or at least buying a 3D printer. I know that sounds a bit, simplistic, but, the entry point or the cost of 3D printers has significantly decreased. 3D printing has almost reached a stage now where it's a consumer experience. You can buy a 3D printer out of the box and start printing straight away. The technical gates have reduced significantly to a point where 3D printing is approachable to almost anybody. But of course, if that's not your cup of tea, then the other options would be to find someone who does have a 3D printer, obviously, ask them to print it for you. Or I do believe there's a lot of third-party 3D printing services which will print those for you. You submit files and they'll send you the outputted files or outputted prints to you directly. Right, so ladies and gentlemen, we now come towards the end of our update video, and we're going to obviously now discuss the thing that everyone has been asking me for, and that's a variety of additional sizes. So when we started this project, it was very much centered on this version, which is the 4-inch or 100mm version, because that's the version that my dust collection system uses. So that's what we have set up here. But what I wasn't anticipating was just the demand for larger sizes and even a smaller size. So let me quickly go through the new and improved lineup that will be available, and discuss some of the things in regards to the differences, and just introduce you to these new sizes. So let's start at the very small end. So one of the things that was a surprise to me is just the amount of people that obviously don't have larger dust collection systems. They run much smaller ones. So we had a lot of people asking about 2.5-inch dust collector or blast gate balls. So this particular one is based on a 2.5-inch version, and as you can see, it's a manual gate only. So at the moment, I don't have, or I haven't modeled a motor to work on this one. I think a micro servo will work just fine, or the medium servo one would work absolutely fine. But we need to shrink the size of the components, the electronics, to fit on this in a sort of efficient profile. So I do not have a motorized version of this yet. I will work on that in the future. But for those of you who aren't interested in that and just want a manual 2.5-inch gate, I will have that on my website that you can definitely buy. So it's going to be available in a 63mm version, a 61.5mm version, and a 63.5mm version. So 3 different versions we kind of had to make, and that's purely based on feedback from a whole bunch of people who did some preliminary testing. It seems that not quite 2.5-inch, some of them a little bit more. So we've thrown together a whole bunch of different sizes depending on what you have. The main ones are based on a rocker system that a viewer sent to me. So thank you very much for that. So I based the design off that one. But that one is a 2.5-inch version. Now moving on to our 4-inch version, our original one. So here it is. There's a couple of updates that I've made in regards to the 4-inch version. So the first thing that I've done is I've incorporated servo mounting plates. So this is servo mounting plates that suit all 3 motor types. So micro servo, a medium servo, which is 5.1, and a heavy servo, which is 20 kilos. So you can use all three on this one. There are different mounting plates for that, and there are different servo arm adapters here that you'll need to swap out depending on which one you go for, but that one will support all three motors. Now we move on to what everyone has been asking for, and that is a 5-inch version and a 6-inch version. Now, as you can see, as we go up from the 4 to the 5 to the 6, we have changed the size of the gate significantly. So this 6-inch will probably max out most people's build plates. So if you've got a 256 millimeter or like a bamboo printer, at least a A1 plus or higher, then you'll be able to print this. If you have an A1 mini or a smaller one, you're not going to be able to print 6-inch, sorry, it just will not fit on the plate. You may be able to print the 5-inch version, but that will probably be pushing it as well. And just for comparison in terms of how much additional volume in size, each time we've gone up 1 inch, the volume of the ball gate actually increases by about 40%. So if I put these two next to each other, we can really see the size differentiation. So a 6-inch blast gate here is really, really quite big. And that leads to the next part in regards to motors. So I've just mentioned that the 4-inch, we can use all three motors. This 5-inch, you cannot use a micro servo. It's just too small. So I've got a 5 kilo rated one in here, but I recommend the 5 or the heavy one, so the 20. And for the very big one, the 6-inch, I only really recommend the 20 kilogram one. You can use that one, and I have tried it in it, and it does work. But again, it all comes down to making sure that you've prepped the ball post print, that you've done all the necessary post work finishing on that. So all of those are working just fine. I can't physically test this in a dust collection system because I don't have a 6-inch or a 5-inch port to test it with, but I see no reason why it wouldn't work. I've checked all of the electronics and those are working fine. All of these will work with the AC version. These will work with the battery version, but the battery life on this one will be very bad if you use the small battery. If you do upgrade the battery, you probably last a bit longer, but these ones I definitely recommend you run off AC power instead. So, ladies and gentlemen, that basically wraps up this update in regards to the Blastgate ball valve project. If you're interested in printing your own, head on over to my website where you'll find digital files available for all of the versions you've seen today. I want to thank everyone who purchased files to the original 4-inch version. Your early support is what enabled me to continue developing this design and to be able to release these other sizes. So if you bought those files previous to the launch date of this particular video, then I'll be sending you a coupon to allow you to receive a free update. And as an additional thank you for your early support, I'm going to be sending a 50% discount code that will allow you to buy any of the other sizes that you might be interested in. So if I'm describing you, keep an eye on your email as you should be receiving those coupons shortly. This has honestly been one of the most rewarding projects that I've ever worked on. I love receiving your emails, especially from those who have taken my design, printed them, and sent me pictures of them deployed and working in their workshops. I love all your questions, and I also really appreciate all the people who have given me constructive criticism. It's actually helped a lot in terms of refining the design and making it a little bit better, as well as explaining some of the things that we've done today. As always, I want to thank my current channel members. Your ongoing support makes these kind of videos and these projects possible. And your continued generosity is really appreciated. And a special shout out to my 2 newest channel members, Guy Holmes and Rod Vetcher. Thank you so much for your generosity and welcome to the Barber's Paddock. Of course, if you have any comments, questions, queries, suggestions, please pop them in the comments below. I generally read them all and I always respond. And yes, I do promise that there will be some woodworking shortly. I have a couple of projects that I need to do. There is a very big laser that's currently sitting on the workbench just behind the camera that desperately needs a new home. So that's going to be our next project. So stay tuned for that one. As always, thank you for watching and I will see you on the next one.